TT Forge is our compiler project, our ML compiler project. It's built on top of MLIR. That's kind of our backbone, and it's a lot of fun. So we have a variety of different front ends coming in from Torch, JAX. We also have TVM front end, which is kind of built off of Buddha called Forge FE. That all feeds into our MLIR-based compiler infrastructure, and we run on top of TT Metal. So we can run direct to Metal, or we can run on TTNN, which will leverage Metal kernels underneath. So that's just a high-level overview of our compiler, what it runs on, how to enter into it. The tools that I mentioned are a variety of tooling to help support that. So TT Explorer is a visualization tool to visualize your models, execute them, see the performance. TTRT is our runtime tool. TTIR Builder is a tool to generate TTIR modules within the context of TTMLIR. So these are just some of the tools that you'll find available within the stack. For more information, definitely check out the repository. We have an awesome mermaid diagram, which will kind of display where everything goes. Yeah, so Stephen, to answer your question, you don't need a Tenstorrent board nowadays. We have Koyeb, our cloud provider. I know that they've been providing cloud instances with wormhole cards for people to play around with. And if you're just interested in the compiler component, it is almost like without the runtime itself, it's basically standalone. So you can compile MLIR modules and kind of read the IR as it gets spit out without needing the silicon itself to run it. But to run it, you will need the silicon. So that's just 2 cents there.
So I'll just keep asking questions until other folks come in and maybe ask any questions that they have. Oh, good. We got one from Brian, actually.
Yeah. So do I have a list of things, summary of types? Yes. Okay. So in terms of modifying like knobs at runtime, so like what specifically gets run and what doesn't get run, TTRT will basically take our flat buffer format, which gets submitted out of our compiler, and then it'll allow you to, oh, yeah, sure. So the question from Ryan is, which tool allows you to turn knobs and dials at runtime? TT Explorer or TTRT? Also, do you have a list or summary of the types of things I can modify at runtime? And yeah, so that's the question in terms of answering the question. So we have our flat buffer artifact, a binary, which is emitted at the end of our compiler. So TTRT is the tool that we use to execute that flat buffer, but it is basically stationary besides the input tensors that are provided into it. There is really nothing much that gets modified there. To modify the actual IR itself, or what gets executed, TT Explorer would be the tool there. It'll help you visualize the entire graph of what's being executed, and you can modify certain attributes of different ops. So create some like op level modifications for things like changing the data type, changing the grid layout, so on and so forth. A list or summary of the types of things you can modify. This is good. This is a good point. I think we have some documentation on what can be modified for Explorer, but it's definitely not fully fleshed out. So this is definitely something that we'll take into account. Using TT Torch front end with TTMLR and TT Metal 1, I can build TT Metal's Tracy via TT Torch toolchain, CMake list, but found a few build related issues to run Python M Tracy on the Python file. Any idea when this can become more stable? Yeah, so I know that the way that Tracy is packaged with TT Metal is definitely a little weird. There's definitely some nuances with it. To make testing with Tracy pretty stable, we've kind of used this TTRT tool. So I know that running with TT Torch, it won't necessarily be easy to do that, and it's difficult to get the IR that's kind of emitted in the interim. But the TTRT tool packages Tracy up in a nice way. That being said, using Tracy and more debugging tools with TT Torch is definitely something that we will look into moving forward, and kind of that incorporation between TTRT and the front ends. So yeah.
It looks like we've got a few more coming in. That's great. I could probably read them out to you if you want, or just.
No, I should keep it better.
Okay, good.
Okay, sure. So Christopher asks, right now it looks like all the models are implemented by hand using TTNN. What's the timeline for the compiler to be used for production? So there is definitely a pretty, long development cycle ahead of us, but I think we've made some pretty good progress so far. A lot of our tests and stuff are implemented by hand. And even in terms of like transformers and these larger models, they're also implemented by hand. So it might take a while for us to get, up to speed with supporting everything, but we're definitely getting there. And so I'd say keep an eye out for our alpha release, which is coming up. And then moving on from there, we'll definitely have more and more releases as we start increasing the fidelity. In TTSMI backend, we're getting this integer value, ASIC temperature. I need to get the temps of the card without any Python involved. Where's the equivalent C code in the repository? I'm not actually too sure about TTSMI, so I haven't worked with that tool directly. That's not necessarily within the scope of the compiler. That being said, there is definitely some hardware helpers to get the temperature. In terms of Linux, I was using cooler control for a while, and that's hardware manager picked up the ASIC temperature pretty easily. So I'm sure there's some endpoint to receive that information. I'm just not sure where it might be. So maybe you might be better off asking on the Discord. Okay, when will that become available? I'm not too sure when the debugging, so Joe asked when will that become available? I assume this is related to the TT-Torch debugging. I'm not too sure what the timeline for that will look like, but it's definitely something that's on our radar and something that we're looking into. But I just can't provide a concrete date. Will a Llama 4 test model, can become available? Joe, I think that these test models will probably exist in TT Transformer before they come into Forge. And so TT Transformer is where we have a lot of our LLMs, and that kind of developed by hand for TT Metal and TTNN. So 100% keep an eye out there. I don't necessarily think that that'll be available in Forge as soon as it will be in TT Transformer. Right now, all the kernels are using manual fusions. Will TT-MLIR solve this? Yeah, we're hoping to do a lot of nice rewriter patterns to catch certain things so that we can fuse operators. So this is definitely something that we currently have at a small scale, and we're planning to kind of grow as we start increasing the amount of fusions. Considering both TT-Torch and TT-XLA emit stable HLO, there's definitely a lot of space to start adding more fusions in. So it's definitely something that we're in development of and have developed. So does TT Explorer change the way we can test quantization schemes? It's super cool to imagine changing data types flexibly and test them. Yes, this is something that we're definitely incorporating a little bit more of. Currently, the way that we change data types is a little bit rudimentary. I wouldn't say that our compiler has first-class quantization support in TT Explorer yet, but we are in active development of that right now. And so it is definitely something that should be available in the next coming while. But yeah, it would be really awesome. And that's kind of the vision for the tool, to make it super easy to kind of hook into our compiler, apply some overrides. If you're interested in those and see how that runs on our hardware, kind of play around with the code and everything. So that's a lot of the fun there. Llama 4 is available on Hugging Face Transformer already. Yeah, I'm not too sure where we are with TT Transformer. Again, I'm not necessarily an engineer on that team, but I definitely would suggest checking out that repository. What about model training? Yeah, so we have a model training framework that's being built up with TT Forge. And so the way that we plan on kind of implementing it is kind of making the compiler a little bit agnostic to what's actually going on, if it's like a forward graph, a backwards graph, or so on and so forth. But make it super easy to basically leverage the autograd from whatever front end we're using, whether that be Torch or Jax or whatever, and then just run that graph as if it were any graph on our hardware. And so we can kind of have that play out. So we get a lot of that compiler optimization for free for the autograd, and then we just kind of play into running that graph as well as we can. Christopher asks, is the DSL going to be similar to the new Qtile? I'm not so sure. I haven't played around with Qtile specifically. I've played around more with Triton. It's definitely Triton inspired. So 100%, it might be similar to that, but PiKernel is definitely something that's in development. So I would say it's like way pre-alpha, but it's a lot of fun, and we're leveraging some of the passes that we have for TT Metal compilation, like direct to metal for that. Can Wormhole run Flux? I am not aware of what Flux is, so I can't necessarily answer that question, but let me Google it. Oh, it seems to be a transformer model, flow transformer model generating images from text. Yeah, for a lot of these models, I would say for now, the implementations would probably be on the TT Metal repository. If they are not there, then our compiler is definitely reaching the point where we can start, you know, creating the code or compiling these LLMs to run on our hardware. But I'm not sure if at the current moment Forged would be able to do it, but 100% take a look at the TT Metal repository and TT Transformer repository to see what's going on there. Maybe others on the team are more familiar with this than I. Okay, does quantization, okay, wait, hold up, there's more questions here. There's some questions in the chat and some in the Q&A, so I will flip between the two. Okay, this is not related to TT Forge, but my question would be, what is the closest you have to a general purpose matrix multiplication in TT Metallium? What I'm most interested in is support for row major matrices that are stored in DRAM without special padding requirements. One technical question I have about this, if I were to build this myself, is how to handle dimensions that are not multiples of the tile size. Can I only load parts of a tile? And what's the best way to mask parts of the tile that are outside of bounds? Yeah, I know that there's like a large series of matrix multiplication kernels written in TT Metal. 100% suggest taking a look at those. They kind of implement them in different ways. In terms of like a fully general, fully dynamic one, I'm sure that exists, like for a gem. In terms of like making one for yourself, which would be a lot of fun, I think like, if you're not operating within the multiple of a tile, that you would have to somehow pad it, or somehow fill in that gap. There's different ways of doing this, and so 100% just take a look at the different kernel implementations and see which one fits best for your certain scheme. Tests have been added for Flux and TT Forge FE. End-to-end support is yet to be provided. Oh, that's awesome. Cool. Well, I'm happy to know that Flux is supporting TT Forge FE. That's awesome. Yeah, that's really cool to see. So we'll see how that happens. Does TTN quantization happen on FP32 to int8 and int4? So the quantization support that we have on our backend, I think it does support int8 and int4. In terms of how the compiler determines that, you would have to apply that through the front end, and then we'd be able to quantize it from there. Can we add an environment debug directory flag to allow all generated .mlir outputs to be stored under this debug directory? Currently using debug, all MLIR are displayed on screen, and I have to modify a few Python files to dump them. Oh, that's a good point. Yeah, we kind of just spit out MLIR files wherever, but it would be good to kind of specify a path for where those should be dumped. So this is definitely, I would definitely suggest filing an issue or something. And this is something that we should totally look into to ease out the developer experience.
Any other questions? Feel free to keep adding questions, but in the meantime, if folks want to get involved and contribute to TT Forge, what are the areas that would be of interest or the best way to do that?
Yeah, 100%. So it really depends on what part of the compiler you want to be involved with. If you're more interested in the front ends and the integration with things like Torch Compile and so on and so forth, 100% check out like TT Torch, TTXLA, TT Forge FE, see how we're kind of hooking into these front end graphs and optimizing them. And file issues for that. I think for a lot of developers, an entry point is going to be the front ends. And I admit that I don't have the most experience with them. But it's definitely the easiest entry point, and it's probably the coolest entry point. So check it out, see how it works, see if anything fails. If anything fails, file an issue and kind of go through that. There's hopefully documentation. If there's gaps in the documentation, file an issue again. There's a lot of space for us to improve, and we'd love for people to get involved and see, what it's like and see what we're up to. That's why we keep everything open source, and that's our mission here. What's up with the Torch 2.0 compiler versus whatever it's happening at the TT Forge end? Yeah, so the Torch 2.0 compile, we basically just create a backend for that, and that backend hooks into our TTMLIR compiler. So what's happening is we take that Torch FX graph, and that is our input. We put that into Torch MLIR, and then that Torch MLIR emits stable HLO, and that stable HLO is the entry point into our actual code. Like our TTMLIR compiler, and that's where it kind of gets optimized. And TTXLA in a similar, well, different but similar way emits stable HLO, and that stable HLO is going to be kind of through that same entry point entered into our compiler to eventually be turned into a binary flat buffer, which is what we execute. All right. Ryan asks, I'm interested in contributing on the data type side of things. Which repo do you recommend I study and play with? If you're interested in the data type part of it, then 100% it would be TTMLIR. You should check out some of the stuff that we're working on with quantization support. So we're adding quant dequant ops to our TTNN dialect and our TTIR dialect, and we're kind of increasing the fidelity of those and making sure that they're working well. So TTMLR would be the place to work on that. And I'm really happy to hear that people are interested in that. How's the Blackhole specific optimizations on the compiler going? Seems like handling the L1 sharding is going to be challenging. Yeah, probably. I'm not too sure how the stuff with the Blackhole bring up is going on in terms of our compiler. I know that it's definitely something that we're kind of implementing and looking into, and also something that works. But in terms of Blackhole specific optimizations, it's definitely something that we are fleshing out as we go forward. So currently, yeah.
Until the next question comes in, I'm just going to plug our bug bounty program. I just dropped a link in the chat. It's a GitHub link where you can view all of our open bounties for contributing to our tech stack, including some for TT Forge. So check out what's available there, and you can look into picking something up if you're interested in contributing and making a little money off of helping build out these features.
Awesome. Yeah, so Scott, I'm interested in getting TT Metal compiler up and running on FreeBSD. Has this been tried? Any suggestions on where to start? I know one of our community members, Marty, is super passionate about kind of porting over TT Metal to Arc or Arch and other places where it hasn't really been. So 100%, there's a lot of community members that are interested in this. I'm not necessarily sure in terms of FreeBSD if anyone has tried that specifically, but it would definitely be something to look into. And put some messages on the TT Metal channel on the Discord, and I'm sure there's a lot of people who'd be interested in checking that out. So Zahid asks, why Torch MLIR is not considered for importing Torch models to MLIR stack? So we do actually use Torch MLIR, but it's kind of integrated with our TT Torch. That being said, we do maintain a fork called TT Torch MLIR. It is a fork that we maintain for the key functions of Torch MLIR that we end up using in that kind of compilation step there. So I think it is an entry point. I just don't think it's been like a fully fleshed out entry point. So maybe some more documentation there, or maybe I'm not aware if there's more documentation there. So 100% check out TT Torch MLIR and see what that looks like. Not sure if this is something that would be beneficial, but if we have some guidance as to where the open source contribution is needed, skills, first good issues, would be beneficial to open source contributors. I 100% agree. I know that we've had the tag for good first issue for a while, but it's seldom applied in my opinion. I definitely think that developers should, like we as engineers, should be taking more initiative to kind of add that tag on. And with the whole bounties initiative that's going on, I definitely think that that's kind of growing in terms of like, where things are being applied. But in terms of some documentation for open source contribution, I know that we're working on our contributing files and everything as well. So hopefully it becomes a lot more seamless experience for those who are interested. And we have more issues for you guys to check out for the bounties and other stuff as well. Where's the link? I think the link is above Scott's message if you can't see it. Is the Blackhole specific optimization will be on Forge compiler or TTMLIR or TT Metal? Yeah, so TTMLIR is a component of the Forge compiler. In a way, you can imagine it as like the main functional component that does a lot of the transformations and the lowering between the different IRs. So a lot of those optimizations will probably happen at the Forge, like within the Forge compiler. If there's any specific optimizations related to the execution graph, if there's any optimizations related to the kernels themselves, those would be happening in TT Metal. Please try to put questions into the Q&A so they don't get lost in the chat. Yeah, I'm trying to read both, so hopefully I can. Josh, yeah, it'd be awesome if you could take a look at OpenBSD. That'd be really cool. Is training possible on TT cards? If yes, where can we find references to train the LLMs? I definitely think that we have training infrastructure. You'll find some training documentation on the TT Metal repository. And let me check if this is open source, actually. If it is. Oh, hey, oh, no, it isn't. Never mind. And we're developing some training frameworks with TT Forge that can be grown out. So hopefully that becomes open soon and you guys can access that. Is it possible to contribute to TTMLR without having any silicon in my local system? Yeah, Zahid. So there are definitely some TTMLIR features. Like I said, the compiler itself is kind of standalone except for the runtime. So if you're aware of any compiler optimizations that are not going through or any small bugs like that, it is 100% possible to kind of add those fixes in. We even have a Mac build that's supported if you want to go through that. That being said, if you want to test some of the runtime features and see if that gets lowered to silicon appropriately, you might have to go, either use the Koyeb servers or get some other access to silicon. I don't see the link I have. Okay, hopefully that link is there. Where can I access Wormhole N150 without buying it? Yeah, thank you, Ryan, for the Koyeb thing. Yeah, that'd be 100% really useful. Um, okay, cool. So I see some messages here. Okay, how's a black hole? Is this company directly related to Tenstorrent? I'm not aware, I'm not sure what Koyeb's relationship to Tenstorrent.
I can take that. So Koyeb is one of our cloud partners. So
Okay.
they have some of our hardware, and we collaborate with them so that you can try out Tenstorrent hardware. Yeah, so that would be the link you'd want to check out if you're curious about trying before you buy.
Awesome, thank you. Luke asks, what TT software can I use to run simulated JAX Flax devices on Tenstorrent cards? Um, I think that would probably be TTXLA. That's probably the endpoint that you're looking for. And that will probably provide you the entry point into using a lot of the JAX models and how that gets imported. Otherwise, you can get that to export to stable HLO, and that'll also be an entry point into our compiler. In the TT metal only flow, its compiler frontend can access device-specific YAML and core YAML configurations. In the TT torch slash TT MLIR flow, I saw a binary slash temp TT-sys file or TT-SYS file. Is this file the device-specific configuration file? If yes, is there any doc I can read to understand more? Yeah, that is the device-specific configuration file. That is our TT system descriptor. We do use that for a lot of our compile steps. I don't it might be available in the TTMLR documentation to see what it's comprised of, but for like a super detailed overview, if you're familiar with the flat buffer schema, you can just read the flat buffer schema to see everything that's present and gets populated in there. If you don't notice that there's any documentation, please file an issue. We should 100% be adding that. Is there any KT vids or docs that would help first timers? I'm not sure what KT stands for. Sorry, but in terms of like documentation and videos to support, I know one of our engineers, Nicola, created like this awesome intro to Forge video that's on our YouTube channel. So you can check that out to see what our stack is like. That being said, almost all of the sub projects have their own documentation that's written out. So hopefully that provides like a good entry point to kind of read more into our stack. But start at the main TT Forge repository, and then you'll see an interactive diagram to see all the projects and how they relate to go through there. What level of interest is there in supporting connecting? Okay, what level of interest is there in supporting connecting another device like a switch or other network cards over the QSFP Ethernet cables? I am not sure about that. That's not necessarily something that's within my domain. That being said, that'd be really cool. I know there was talk on the Discord about attaching a few high-speed FPGAs or something to it and seeing how to get that out, but I'm not too sure. For that, I'd take a look at something like TT Fabric and stuff and see where that kind of leads and gets spit out. But yeah, that definitely would be a cool thing to look into. Okay. Is there any quantization support available at the Forge compiler? Yeah, we're adding quantization support in. And so you will see that it's kind of in development. So it might be difficult for the front ends to provide that information and get that fed through immediately, but it's definitely being added in. And so, maybe I say it's not in today and it'll be in tomorrow. So it's definitely something that's in very soon. So definitely keep your eyes peeled for that. What kind of optimizations will be done in specific to Blackhole slash Wormhole cards? Can you give some examples? In terms of like the specific optimizations that are planned for Blackhole or Wormhole cards, I'm not sure. I know that when we're heading into Blackhole, there will definitely be discussions about leveraging those X280 cores with our compiler. We have something called CPU hoisting, which will basically take some of our operations and hoist them on CPUs, where we use Linalge to LLVM pass. So that exists to basically as a backup in our current compiler. In case we have any issues, we can host some of the operations on the host CPU and basically run that dilib to then retrieve the results and pipe that through. So maybe some mechanism similar to that could be leveraged to use some of the X280 cores in the Blackhole in case it's better for certain operations, which require more control flows, maybe like top K, for example. That being said, I'm not sure like what specifically those optimizations will be. It's definitely something that's planned. That being said, there's a lot of cool potential now that we have those extra cores to work with. Any plans for Tenstorrent Hackathon? Yeah, keep an eye out on the Dev Hub. It's a really cool website. I saw it recently. I was like, damn, this is pretty awesome. Okay. What unique feature that boosts Tenstorrent ASIC cluster apart from CPU core? So the unique part of it is that it's attached to our NOC. And so that makes it a lot easier to kind of retrieve and send information through. That being said, I would say like the specifics of the X280 cores are probably better documented elsewhere. Check out some of the tech reports and stuff related to the Blackhole chips, and you might be able to see how the CPU itself performs. But the main advantage is that it's hooked up on our NOC, and we're able to use it. So that's kind of one of the main advantages there, that we can easily hook into it and it acts as part of our core grid. I don't know. To answer your question, Ryan, I have no clue. Ryan asks, when will Blackhole P300 drop? Maybe this is better suited for someone else.
Yeah, so we don't have public dates for that yet.
Yeah, makes sense. Is there any tensor acceleration module attached to the NOC? Yeah, so we have our main tensor core. So that's the Tensix itself. So each one of our Tensix cores acts as kind of like one of this acceleration units. So it has an FPU, which is like our main kind of processing unit to do the computations, alongside 5 RISC cores to control, 2 for the NOC control, 3 for the computation itself. So these Tensix cores kind of act as the acceleration modules, and the grid of Tensix cores comprises of our main AI accelerator. So in both Grayscale and Wormhole, that was the main PCIe card itself. Now with the introduction of the X280 cores, we can start to see a bit of heterogeneous compute, where we have, some CPU cores and some of these specific tensor acceleration cores. And that's kind of where that potential for different optimizations comes in from. Okay, what specifically are you two working on now or excited about over the next 2 months or next few months? So I think I mentioned this at the start, but I'm working currently on PiKernel DSL. So this is a DSL to write TT metal kernels in Python, just for quicker prototyping and easier usage as a developer. I know that when I wrote TT metal kernels, it was a gigantic pain. So this makes my life a lot easier and it makes developers' lives a lot easier. So maybe, it's a really cool project. It's kind of leveraging a lot of the compiler passes we do for direct to metal. So it's a part of the TT MLIR project for now. I also prototyped the TT Explorer tool, which is this graph visualization tool and performance monitoring tool and accuracy monitoring tool in TT MLIR. So that was really cool. And I also maintain the Python bindings. So if you want an easy entry point to creating MLIR and use some of our TT primitives, then you could use our Python bindings and it'd be a lot of fun. So yeah, it's currently what I'm working on. What I'm most excited for is kind of bringing up a lot of the front ends, a lot of the entry points into our compiler and having people play around with it. So thank you everyone for joining this call. And it's really cool to see everyone interested to check this stuff out. Okay. Is there any documentation / demo video for the usage of TTNN Visualizer, TT Explorer / Tracy? So TTNN Visualizer, I know that they have some demo videos. TT Explorer definitely does need some video documentation. So I would love to work on that and maybe you'll see something soon. Yeah, Tracy and stuff as well. I would definitely check out the metal tech reports for Tracy. You'll see some stuff there, but not necessarily a video for Tracy. But for the usage of TTN Visualizer, there's definitely a lot of good, strong documentation. Suggestion, bridge cables for N300 instead of fixed by slot. I can't keep them too close because the heat and I need to test with different NUMA configurations. Could be interesting. Oh, awesome. There is a video on TTN and Visualizer. That's sick. Okay. Yeah, TTN and Visualizer is an awesome tool. 100%. If you have the chance to check it out, I would suggest.
I guess I'll chime in on what I'm going to be working on and what I'm excited about until the next questions come in. So we're really working on, now that our developer hub is live, continuing to grow the content that's in there. So I really appreciate these questions and these requests, because that helps us figure out what content is relevant to you and what we need to add to that, and really just trying to grow the community. So great question about hackathons. So looking into things like hackathons and events to get out there and hopefully tell more people about Tenstorrent and get them excited about it. So that's kind of what's going on my end. And so actually, as for part of that, it's going to be these monthly office hours and also monthly webinars. So check out either on our Discord, I've listed it, and also on our Meetup page, and it's also on our Dev Hub. You can see those events, so you can check them out as well. But yeah, we'll have these going on monthly, and there'll be different parts of the stack involved with each one, and then also the webinars. So really excited about that, getting more of this conversation continuing to go on.
Yeah. No, it's been really awesome to see all the developers coming out, and it's cool to see people using our code. So on the engineering side, it's super awesome. And again, if you ever come across anything on the tech stack, send a message on Discord, file an issue. We're more than happy to help and answer your questions. So yeah.
Any other questions?
When will Forge adapt to the latest TVM Relax update? So we maintain a fork of TVM called TTTVM, which is used in our Forge FE component. And so I think they do uplifts. I'm not sure what their uplift schedule looks like, to be honest, but I'm sure that this might be on their radar to uplift and implement that. I think that's pretty big update, so it'll definitely help out. We'll see when that gets added in. But for more progress on that, definitely check out TTTVM and see what their uplift schedule looks like. I think that repository should be open. Is there someone in the product or sales group to talk to you about it licensing and raw chips? Yeah, Troy, definitely reach out to I'm not sure if there's anyone currently, but I'm sure someone will reach out to you.
Yeah, Troy, we're already in contact, so we can talk about what IP licensing looks like, and I can get you the right contacts in that department.
Awesome. Thank you so much. Oh, maybe my last question before bedtime. I'm following Yan LeCun on the future of AI beyond LLMs. What are your guys' thoughts on that as you develop TT Forge, TT Metal, etc.? Yeah, that's a really fun question. So I actually come from a background of doing research on the spiking neural networks, or SNNs, and so I know that's like a big kind of trend word recently. And so there's a big future to AI beyond LLMs, and there's a lot of stuff going on. And at Tenstorrent and TT Forge specifically, our focus is definitely on generality. We want to include as many different types of models as we can under our umbrella, and kind of implement ways to execute them, and ways to execute them performantly, right? So this is definitely something that's on our radar, and we're keeping an eye out on future architectures and seeing how we can incorporate these new types of models with our compiler and still make sure that it works well. So there's a whole world of AI out there, and there's a lot of cool stuff. And hopefully we can support a lot of that as we move forward.
Any other thoughts? Oh, looks like we got something.
Why are we not having LLVM backend for binary gen? So we do actually use the LLVM backend for that pass that I mentioned before for the CPU hoisting. That being said, we don't use the LLVM backend because we have already like our compilers to generate like these RISC-V kernels, which get deployed. And that is already built out through TT Metal. So instead of taking on that legwork within Forge itself, what we do is we basically just emit like either TTNN supported flat buffers, or we emit metal kernels directly and have those compiled through our metal compiler. So we're not leveraging the LLVM backend for binary generation for our 10.6 cores and such, just because we already have the infrastructure with TT Metal. In the future, this could be something that we look into, but for now, I think we have a pretty good flow going with currently existing code and TT Forge. Luke, you're asking what are some of those alternate architectures? I remember like model architectures. So we're keeping an eye out on what could be. That being said, I'm definitely not too aware of like the big alternatives. I think transformers are hot right now, and I think they'll be hot for a while. That being said, research comes out very recently, right? So maybe we'll wake up the next day and there'll be a new model architecture which takes over everything. So we'll definitely see. But we're definitely keeping an eye out. And again, our main focus is generality. We want to include as much, you know, support as many models as we can. Question about virtualization. Any plans to break the card X16 to X4, 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 or X8, X8, and control the chips independently, or something like NVIDIA does with virtual cards? I'm not sure, actually. This would be a great question to kind of forward to the systems team and see how they kind of deal with some of that virtualization and the way that we interface with PCIe. But it could be cool.
Just want to say thank you to everybody that's been sending questions our way. Any other thoughts?
Cool article. I'll take a read through it. Sounds like fun. Yeah, no, thank you, Scott, for joining in. I'm like happy to help out, and I hope these office hours can be like a regular thing between a lot of the different engineers. And yeah, they're really cool to see people interested in Forge and what we're doing. Yes, I remember the Fish AI company. Their articles are pretty viral. So yeah, there's definitely a lot of area for improvement, and a lot of cool stuff happening. So again, our hope at Tenstorrent is that we support all of it, and that's what we're doing with Forge. Luke asks, can you go into more detail of your day-to-day on Forge code? Yeah, sure. So I wake up and then no, I'm kidding. So working on Forge code is pretty fun. There's a lot of kind of it's a very open design space. So there's a lot of areas where we can add things in, and there's a lot of planning. So as the Forge team, we kind of meet pretty regularly and we take some time out to see how the integration between all of these different components, like the front ends, the tooling, and the back end, the runtime, how all of that can kind of fit in together and what our large focus goals are. And you know, we kind of come up with some clear deliverables coming out of that, and then we address those going forward based off of new features and priorities that we want to include based off our stakeholders. So it's honestly a lot of collaboration. It's a lot of different ideas coming in together and then kind of finding out the best possible fit to conform to all of those different constraints. And it's a lot of fun. So in terms of the day-to-day, it's kind of collaborating with a lot of people, talking to people on other projects and other teams, seeing how they'd be impacted by the changes, seeing what they want to implement, and then adding that in. In the chat, we have a question. Do you have plans to release any Google Colab like notebooks for everyone to try out TT hardware? So I think Koyeb gives a VS Code instance or some sort of like web instance that you get access to. In terms of like Google Colab like notebooks, I think that'd be a lot of fun. I'm not sure if TTNN, so TTNN is kind of like a Python bindings. It's like Python bindings for the TT metal kernels, kind of like a Torch-like API. I'm not sure if they actually provide notebooks directly. As far as I'm aware, I'm not sure. They might actually do that at the current moment. They might not. 100% check that out if you have a chance. That being said, this is something that could really easily be added in. The difficult part would be kind of the cloud service to actually push RTT hardware as a backend for these Colab notebooks. So that'll definitely be something that, you know, maybe people look into. But in terms of if you have your own hardware and you want to run a notebook on top of that, that would be pretty easy to set up and kind of fun. So maybe that's something we could look into.
I believe we have some Jupyter notebooks, not Colab specific. So I'll find the link for that and drop it in the chat.
Awesome. All right. Troy's asking, how big of an LLM model can you train on a single P150 or P300? Not sure, to be honest. I'm not sure. I'm sure those numbers exist somewhere, but maybe other engineers are better. I think check out TT Transformer. I know I keep referencing this, but for LLM stuff, definitely check out TT Transformer and where that code is. They probably have some stats reported on what they have trained and what they have working. And that might provide a good semblance to see what's possible. A lot of that is written by hand, so that's, you know, link for TT Transformers. Try finding that. Or maybe if Jen, you have the link on speed dial or something, that would be helpful. No, all right, cool. I'll look for it then. There's a link to TT Transformers.
Awesome. Well, oh, looks like we do have another question. I was going to say we're very nearly out of time.
Question about TT Forge, C source. Is this all the C code needed to build TT Forge without any Python binding? Totally bypassing Python is the goal. As far as so TT Forge relies on TT-MLIR as a dependency, which in the end relies on TT Metal as a it's a long story. That being said, a lot of that we have a lot of flags available to turn Python bindings off. So just check some of the CMake configurations and some of the documentation to see how to turn that off in the build process, and you should be able to build everything through. Um, are there any sort of quick start documentations on how to do training on a single card? Like if I wanted to classify images of plants as a crop or weed? Yeah. I think that's the TTNN documentation is probably the best way to start. It is almost exactly like a Torch-like API. And so if you're familiar with, PyTorch, it's a pretty immediate shift between the two, and you should be able to figure out how to write that code in. If you're interested in trying out Forge, then I would 100% recommend, writing that Torch module as you would normally with that data, but then piping it through our compiler and seeing what gets spit out, and you can try that out. So there's two approaches there, and both may have their own benefits and disadvantages. But that's probably the easiest way to get started, just the same way you write normal code. But you will have to set up like TT-Torch or TTNN, so maybe a little bit more setup. Is TTNN and TT Transformers the same? So TT Transformers is a component of the TT Metal repository. So it's kind of like this repository of models, like almost, yeah, it's like a repository of models and the required kernels and such for models executions within the context of TT Metal. And so TTNN is kind of like the Python bindings that are put on top of that. So TT Transformers is also kind of bounded in a similar way so you can access it, but it's not the same. These are all components of a larger project, but kind of put outwards for users to access. So it's built on the same backend, which is TT Metal, but it's not necessarily like the exact same thing. TT Transformers is more so a use case of TT Metal. Troy says, well, normally I write C++ code, not Python, so Torch is new. Oh, well, Torch or TTNN has C++ bindings as well. You can call it through C++ if you'd like. Or if you'd like to write the TT Metal kernels yourself, you can do that if you're more of a systems person. That's, both are definitely very valid ways to get started. Yeah, the compiler, I'm not sure if we have any C++ entry point. We have C++ exit points. Yeah. So if you just want to write C++ and get AI models running, I think TTNN is probably the easiest way to do that on our hardware.
Any final questions, final thoughts?
Yeah, no worries. Thank you so much for joining. And yeah, thanks, Jen, for setting all of this up. It's awesome. I'm glad to see the developer community thriving.
Thank you to everybody who asked questions. And if you still have burning questions, please join our Discord. That's a great place to chat to people. And if you have any issues, as Raj said, be sure to file issues on the relevant GitHub repo. That's the best way to make sure that that doesn't fall in the cracks. Yeah, and I welcome any feedback so we can make these sessions as productive as possible for everyone in the future.